castle where the digital dreams come alive. CESCG takes place from May 1 to 5, from visualization to the virtual
Thank you.
space.
Hello, everyone. So my name is Elizana Solo, but most of my doctoral dissertation was published before marriage. So I also put my maiden surname if any of you are interested in my work. At the University of Sarajevo, I worked for 2.5 long years with my mentor, Professor Ingmar Vesic, working on cause-effect graphs. So logically, the first question everybody at this conference is going to ask is, what on earth are cause-effect graphs? And I'm going to ask you, have any of you heard about cause-effect graphs before? Please raise your hand if you have. So yeah, basically nobody's heard about it before, and it's a big question why I am at a computer graphics conference talking about this topic. So cause-effect graphs are actually a technique that is used in software quality as a black box testing technique. Black box basically means that we do not know what's inside of a system, we do not have any knowledge about the programming code, and we use this technique in order to be able to test such complex systems. Actually, they have such a large amount of practices for large domain systems, complex industry systems, and for example, you would use this to test an airplane, a missile system, military systems, and other things. And as you can see on these images, the cause-effect graphs were created like a simplified way of showing logical diagrams, like logical hardware circuits. So what does this have to do with computer graphics, and why am I here? So basically, when I was beginning my career as a teaching assistant, I was teaching software quality, and I was really frustrated because I couldn't find a software tool anywhere that would help my students make cause-effect graphs. So basically what they did was create cause-effect graphs on paper, or they did it in Microsoft Paint or some other tool, and it looked horrible. And they were really angry at me because they thought I was harassing them for making them create these cause-effect graphs. So the first idea behind my PhD thesis was, why wouldn't I make a tool in order to help them? But then when I started researching on this subject, I realized that it's a total horror. So there is like this graphical notation, but nobody follows it. Nobody knows what the graphical notation means, this like standardized notation that everybody is supposed to use, and everybody uses it however they want to use it. One researcher uses it the way they want to, they interpret the definition of the elements in one way, and another researcher is going to interpret it in a totally different way. So we get these examples where this person just decides to use this type of notation, and we have no idea what he was trying to say. Whereas another person uses these bounding boxes, and it was obviously drawn in Microsoft Paint. This is a conference paper. And watching over this, I realized that I needed to create a standard, or basically use the textbooks that are accepted in literature and try to show people that they should use standardized notation if you want people to understand you. But it's not just easy to say, please let's use this notation. We have to show it by example. So in my further research, I tried to find an existing software tool that does this work. And yeah, I found 4 software tools, and let me tell you all about them. This tool is really expensive. And apart from that, I also have no idea what the elements here mean. So they use a graphical notation that's not accepted, and it's really expensive. I actually asked the author if I could buy it. And they asked me, what do you need it for? And I said, well, I need it for my PhD research. Please, can you let me buy this software? And they never answered. So I wasn't even able to buy this tool. This tool was made in Windows 7. Of course, the author never answered my emails. I tried to spam him, but I was never able to get a hold of it. Apart from that, you see that there is no graphical notation. Okay, let's move on to 2021. There was a researcher who made a tool. What is it missing? Well, it's missing graphical elements. It's open source, it was made in Java, but I do not have any use of it because it doesn't use any graphical elements. And recently we have this Korean tool that unfortunately cannot help me in any way because it uses the Korean language and then offers like a graphical insight out of system requirements. So again, I didn't have anything usable for my research. So I decided to do it from the bottom up, to do it from the very beginning, and I proposed a solution that I called ETF-RECEG, which is basically the name of the faculty I come from, and cause-effect graphs. Since I started working on this 3 years ago, back then I wasn't that good in web development, so I made it as a Windows Forms desktop solution. It is completely open source, you can try it whenever you want, so it is free for usage, and my students have been using it for 3 years. And at the very beginning, they were kind of not so happy about using it because they had many problems. As you can see, the user interface is very simplistic, but I couldn't really understand the way my students think. So when they started using it, they started reporting multiple problems. For example, if you want to add a new cause on the graph, you just have to drag and drop it. But this is a button. And they kept clicking on the button and nothing was happening. And they said, I cannot use this tool. Then when they started to make logical relations, they had to keep clicking on the nodes, but in the correct order. You first have to select the causes, then the effects. But they didn't know it, and then they just randomly clicked on the user interface and it started breaking down all over. In the end, I was able to sort it out with them and had a lot of help in order to debug and create an entire user interface that is actually user-friendly. But it was really frustrating because if you look at it at the beginning, it looks really simplistic. But who am I to say that somebody is not going to try to add a cause instead of on the left side of the graph, on the right side of the graph? And if you see all of these logical relations that related to computer geometry, they all depend on the fact that the causes are on the left side and the effects are on the right side. So if you start using it in the wrong way, many weird things are going to start happening. Therefore, I had to somehow limit the user to not be able to do whatever they want and just start saying messages like, you are not allowed to do that, you cannot do that, that's not the right notation, because otherwise researchers tomorrow would use my tool in a very bad way. Now, in order to be able to use this tool in the future, we made this import-export feature. So basically, I made up this terminology and this entire textual format that actually encodes all the locations of all the nodes, all the logical relations, so that tomorrow you can reuse the graph without any problems. And we use it in our courses so that when you need to use a black box testing feature, you can import the graph and then begin the testing. However, it's not just enough for me to say everybody likes it and everybody is happy with this approach. We, of course, had to do a user evaluation and a usability study of the tool. First of all, the problem that I had, and this big fear, was that my tool would not be scalable. So that it would be only able to make small graphs because it's a desktop application. But as you can see, the largest graph I could find in all literature, and not many graphs are as big as this one, it was able to create it without any problems. The second evaluation I performed was the comparison to other available tools. Now, as I've already told you, there aren't any available tools that use graphical elements. And because this author of the commercial tool didn't give me the tool and I couldn't make anything in it, I actually sorted through the user documentation and tried to find all examples of graphs as they have shown it. And then I did a user evaluation study where I asked the users, which representation is more understandable to you? Do you like this notation more or this notation? How does the user interface look to you? So I tried to use all images of the tool in order to see whether users liked one or the other representation more. And if you see the results, first, of course, I asked about the experience in computer science, who knew about cause-effect graphs or not. And look at this. Most of the people who took over the evaluation were computer science students. But only 60% of them knew what cause-effect graphs were. So yeah, it's common for people to not even know what this terminology is and to not be able to use it from the beginning. But as you can see, most people like standardized graphical notation more than these approaches which are only limited to a single or maybe 2 or 3 conference papers, and they liked my tool more. They said it was more intuitive, they liked the representations in my tool more than in the Bender RVT, the only other available software tool. So that kind of gave me motivation to move on and to do another usability study. This time it was only focused on the success of using my tool. So I took over many students and many users in general, and then I tried to compare their knowledge of using cause-effect graphs to the success of using my tool. And as you can see, the results are very good. Even though students didn't know how to apply certain relations or what they meant, they were able to successfully use them in the tool. The only problem that happened was that when creating elements, the task accuracy was very low. At first, I wondered why, but then we came back to the beginning and what I told you, that people thought that they should click the button and not drag and drop it onto the user interface. And that's why they lost a lot of time while using the tool. The other metrics really showed a lot of success and that the tool was usable. Apart of that, almost 50% of the users reported no problems. They could use all features of the tool and successfully perform all tasks. And more than 90% of users said that my tool was intuitive, easy to use, and that they liked it in every aspect. So I was really, really happy about that. Of course, that is not all there is to my PhD research. This was actually just a small chunk, a small piece that kindly built to a really big research. So this was basically the first thing that I did 3 years ago, and it resulted in 3 new algorithms for black box testing, the advanced version of the tool, which actually utilizes these elements, which automatically tells the user if they applied something wrong and helps them to renew it and make it better. We also did several case studies which are really interesting in order to see whether my algorithms perform better. And it all comes down to this very beginning and trying to help students create these cause-effect graph representations better. In the end, we published 4 conference papers and 4 journal papers, so my PhD study is mostly done. And the only reason why I'm showing this to you is to show you that it is possible. You may get rejected, you may get problems, but just keep going and your PhD study is going to be recognized in the right circle. So tomorrow, if you're trying to publish a journal paper, remember that crazy person who managed to publish 4, and you won't have any problems. So your PhD studies will be very successful. And for the very end, we need to ask ourselves how we can build up further on what I've done. Well, the things that I didn't have the time to finish is, of course, to make a web version of the tool. All of my colleagues from the University of Sarajevo are like, nobody is going to download the desktop application. So, of course, the next step will be to create a web version of the tool, to make it available on a server so that you don't have to install everything. And that's going to be the next step in our approach. Afterwards, we're going to focus on this Korean approach and actually not use it as a localized, but generalize it to the English language so that you don't even have to draw cause-effect graphs anymore, but you only insert text, and as a result, you get the graphical representation of the cause-effect graph. And I hope we will be able to do it in the next years to come. So that's it for my presentation, and thank you for listening.
Okay, thank you for the presentation. I might have the first question, like, what is the use case of usage of this tool in your field of research, and where do the students use it?
Yes, so basically at this software verification and validation course, that's basically testing things, we try out different technologies. So we try to make all combinations of inputs on a user interface. For example, you have to enter how old you are, where you live, and some other information in order to be billed for a cinema card. And in order for it to work correctly, you have to check all the combination, because if you're a student, if you're less than 18 years old, if you're a senior, you're going to get different validations for a ticket. And in order to test that, we use different kinds of technology. So we try to represent the system as a cause-effect graph, or by using the pairwise technique, the equivalent class partitioning, and other methods, and then we check which one gives out the least tests and with the best results. So this might not be a good use case for cause-effect graphs, because the number of tests will be 3, 4, 5, because you only have 3 or 4 categories of users. But in general, if you're trying to do like an autopilot of an airplane, you have thousands, maybe millions of combinations. And cause-effect graphs will lead you to the smallest number of combinations. That's why domain experts really prefer this technology to others, because they don't understand what an equivalent class is. They don't understand these computer science terms. But cause, effect, those are terms that they can understand. And these logical diagrams, like how a cause affects the activation of an effect, it's something domain experts who have nothing with the IT, they can understand easily. So in that domain, it's really, really largely used.
So my next question is, You said that it's available also for the non-developers. How long do you think it would take for me to teach my QA colleague how to use this?
Well, we made an extensive like a Wikipedia about the tool. The Wikipedia contains a page what cause-effect graphs are. It contains the definitions of all elements. It would take you maybe half an hour to read it. And then it would take you maybe another 10 minutes to look at all of these like GIF images and to see how to use the tool. So I believe that maybe in an hour or two, your colleague, especially since he is a QA, he would be able to understand the terminology and begin using the tool. And then he just, when he creates a specification, he clicks generate tests, and he gets the tests for the system. So he doesn't need to understand how to convert the cause-effect graph into tests. He just needs to click it, and my algorithm will work it out for him.
When you said test, do you mean some kind of test automation, like unit test, or?
Since this is black box testing, no, it doesn't depend on code. It only tells you what you need to activate in your system, and as a result, what you should get. So basically, if you're in an airplane or a simulation of an airplane, it will tell you what parameters to enter, and then when the simulation finishes, or the real system, that is what outputs you should have. Of course, next and future work would focus on that in order to somehow integrate actual implementations of systems into this, but this was only the first step of a large research. Thank you.
So I was wondering about the UI choice of having the button that you have to drag into the canvas to create the element. Why doesn't the button just create the element on a click?
The problem was because of computer geometry. If I started stacking elements one beneath the other, I would somehow disrupt the intention of the method. Because usually when you make cause-effect graphs, it's a dense network. And it's really difficult if you try to do it like the first, the second, the third. It never works like that. Usually you have like a cluster of causes and effects, and then another cluster of causes and effects. And for me, it was logical to somehow have the user drag and drop it wherever he wants, so that if they want to like delete a node and then insert another, they wouldn't have to like drag it away from the bottom to the top or the other way around. So they can just put it wherever they want on the graph.
Yeah, I mean, I can understand this, but if I were to use this tool for the first time, I would always have a problem, I think.
Yes. I totally understand. That's why in the web version of the tool, I think we're going to totally change the way this works.
Okay.
And we won't use buttons at all because people usually associate buttons with clicking.
Yeah.
And they do not think that they should be. Maybe put an image or something else, or not use the drag and drop operation at all. Maybe import it as a text or something like that so that it can be drawn immediately. Yes. But thank you, of course.
Question?
You talked about how the user is creating the cause-effect graphs. Did you also test the interpretation of the created graphs?
Yes.
Because another task may be that somebody else created the graph for me, and how interpretable it is for a novice user.
Yes, it's a very big problem with cause-effect graphs because these logical diagrams are really easy. And due to their easy of understanding and easy of usage, as a result, you can get multiple representations that actually point out the same thing. So for example, you can use 10 causes or 3 causes to represent the entirely same thing. Or you can have totally different graphs, but in the end they have totally similar or even the same logical relations and results. And that problem is a problem that actually came out from the lack of usage of software tools and the standardization and everything. When we evaluated our tool on users, at the very end we asked them, do you understand what you created? And this cause-effect graph specification, would you use it? Do you know what's the use case? Most of the users at the very beginning, when they were just presented with the graph, had no idea what it meant. But by the time they started using logical relations and creating cause-effect graph specifications, they started to understand its elements. Because when you look at it after several minutes, it starts to make sense. Oh, so I have cause 1 and cause 2. And it's a logical conjunction, so yeah, they both need to be active in order to activate the effect. So as they go over the graph and create the relations, they slowly get familiarized with the meaning of the relations and what it actually means.
Okay, thank you.
We do have time for one more question if somebody is interested. the case, you can thank people again.
Thank you very much.
Sing to the beat where the pixels play. From rendering to VR, it's a pixel away.